Okay, today what we're going to start doing is probably, in my opinion, one of the first lessons where you start seeing where algebra can be useful in the real world. For example, if you you probably have heard the old joking word problem where they say, like, if train A is leaving the station at 1 o'clock going 50 miles per hour, and train B leaves an hour later and it's going 60 miles per hour, how long until it catches up? Right? Well, that's actually an algebra problem, and it's actually called a system of equations. Okay? What we're going to be doing today is we're going to be graphing two lines and figuring out where they cross each other. That's, you may not think that's a big deal, but that's a humongous deal because wherever they cross each other, their x and their y's are exactly the same. So that's the point of today. We're going to be graphing two lines and then seeing where do they cross. All right? You can graph them any way you want. Most of the time I would use either y equals mx plus b, or I would use standard form to graph them, but whatever works best for you. Okay? So let's go ahead and get started. All right. Let's graph this first one, negative 1 half x plus 7. So I know I start at 7, so I put a dot there, right? Oops. Put a dot there, right? Where's my other dot? Well, to make the rest of my dots, I go down 1, right 2. Yeah? Down 1, right 2. And I'm going to be real careful making this graph because if you're not careful with this graph, you can actually not know exactly where they're going to cross each other. All right? Up 1, right 2. Let's see, up 1, left 2. Up 1, left 2. Up 1, left 2. Okay, so I'm going to have to be careful here graphing this. All right, so to graph this, it's going to start there, and it's going to go there. Right? So there was our first equation. Second equation, I'm going to do this in a different color so you can see it. I'll do it in red. Well, it starts, this is a direct variation because it's plus 0, right? So it must start at origin. Right? And then what am I going to do? I'm going to go up 2, right 3. Dot there. Now what's cool about this is if you start following your slope, you'll usually cross the line and know exactly where they cross. But I'm just going to go ahead and finish this up. And as you can see there, I just crossed the line right here. I know where they cross now, right? So I'm going to go ahead and make that line. And I'll do it here. So there we go. And that's really all we're doing. We're trying to find out where they cross. Right here, that point is the key to this problem. What is the name of that point? That is 6, 4. So I'm going to go ahead and write that on my graph. 6, comma 4. What that means is that's the only point on the graph where they're if you put a 6 into this equation and you put a 6 into this equation, they would both give you a 4 out for y. That's where they cross. That's called the solution to a system of equations. The second thing you need to do is you need to check it. Just like before, we've been checking everything, and that's what we need to do here. So what we're going to do is we're going to check the answer, 6, 4. And then all you're going to do is put 6, 4 into both equations, making sure they're both true. So y is 4, so we're going to have 4 equals negative 1 half of 6 plus 7. Now negative half of 6 is negative 3 plus 7 should equal 4. And negative 3 plus 7 does equal 4. 4 does equal 4. Check. This one works, right? Do it for the other one. Y is 4. So we get 4 equals 2/3 of 6. Well, 2/3 of 6, remember how we do multiplying by fractions? Divide by the denominator, multiply by the numerator. So 6 divided by 3 is 2, and 2 times 2 is 4. So I get 4 does equal 4. So there, I graphed them, and then I checked the solution. What's my answer? I do all that work. My answer is 6, comma 4. That is my answer. Okay? Seems pretty simple, right? It's not hard. If you know how to graph already, this is not going to be hard for you. All right, so let's do another example. Okay, I'm going to go ahead and do the second equation now, or the second example now. In this case, you have two options. You can rewrite this in y equals mx plus b, or you can use the standard form cover-up method to solve these. In this case, I'm going to use the cover-up method. So let me remind you how to do the cover-up method. To find the x-intercept, you basically cover up the y and you get x is 3. So I graph that point, x is 3. Then to find the y-intercept, you cover up the x. So I get negative y is 3, so y is negative 3. So my graph is those 2 points. And then I need to make the line, right? So I'm going to make my line there. And then it's going to be doing the same thing going down for me. It's a little bit easier to draw on a piece of paper than it is on this computer. So it looks something like that, right? Then I'm going to do the second equation. To find the x-intercept, you cover up the y, you get x is negative 6. X is negative 6, which is here. To find the y-intercept, you cover up the x. So cover up the x, and you get 2y is negative 6, so y is negative 3. So y is negative 3. Well, that's nice because now I know where they cross. Right there, huh? So I'm going to go ahead and make that line. And I will do it in a different color just so you can see it on here. But it's going to be a lot easier to graph this time because I know that they cross right there. So what's the important point here? Right here is the important point on this entire graph. That's the system of equations. That's the answer. And that point is what? 0, negative 3. Which means they both have the same y-intercept. That's what I'm saying there. They both have the same y-intercept. Which means that's the point they have in common. Okay? All right, and then I'm not done because afterwards I need to check it. So I'm going to say check. And I'm going to check the point 0, negative 3. And I need to check it into both equations. So this shouldn't take long. 0 minus negative 3 should equal 3. So that's 3 equals 3. That's good. And then I try it on the other equation, and I get what? 0 plus 2 times a negative 3 should equal a negative 6. Well, 2 times a negative 3 is a negative 6 equals a negative 6. They both are true, which means that's my answer, 0, negative 3. Now, solving systems of equations, probably the least efficient way to do them is by graphing. But if you don't understand it with graphing, you're not going to understand what you're doing later on. All right? And remember, the whole point of this is you're trying to find out where do these two lines cross each other. Because wherever they cross, they have the same xy coordinate. That's the whole idea behind a system of equation. We're going to spend the rest of the chapter learning other ways of doing it, but this way always works, and you can always fall back on it if you need to. It sometimes is a little bit harder to do because if you can't read exactly where that point is, it gets a little bit harder. But most of the time, if you just graph them, you could figure out where they crossed. All right? Good luck with this.